Section 5 in the finance chapter deals with installment loans and credit cards. The installment loan that we'll be mostly interested in is mortgages or home loans, and then we'll talk briefly about credit cards at the end of the section. So a mortgage or an installment loan works similar to what we see in this table, and we won't go through the whole table, but the idea is that this last plan is similar to what a mortgage does. So if we have a balance that we owe that earns interest as we go, so each year whatever standing balance we have earns interest and that gets added on. Then if we make a fixed payment each year, and it turns out that if we make a fixed payment on this particular loan of $12.52 each year, at the end we'll pay everything off and have a final balance of $0. And where this number came from is what we're interested in. And we'll have a formula in a second to describe where we get this number from. But that's the idea behind an installment loan, is that we owe a certain amount at the beginning, and each pay period a certain amount of interest gets added on, which raises our balance, but then we pay off a certain amount that drops our balance back down, and then slowly over time as we make these equal payments each pay period, our balance drops down and ultimately drops to zero at the end of it all. Skipping some details, we get to this formula that relates P, the principal of the loan, the amount of the loan that we take, to PMT, the amount of the payment. And we notice that this looks similar to a payout annuity, and the reason is that it's similar to that, and there's some discussion here of what makes them similar, so I won't go into that. But the rest of this section, or at least the installment loans part, uses this formula over and over again, getting used to plugging all the pieces in and finding what we need to find. Here's a simple example with a car loan. Given the principal amount on a loan and an interest rate and amount of time and so on, we can calculate the monthly payment from that. And then working backwards, if we're given a certain monthly payment that we can afford, we can work backwards and find the loan principal that we're able to afford from that payment. Here is a slightly different example. We don't actually need to use the installment loan formula. Here we're given a monthly payment amount, and we're asked to find how much we're actually paying over the life of the loan and how much interest that translates to. And this is something that is actually really practical as we come up against loans like this. Maybe after we've calculated the payment amount, we can carry out a calculation like this quickly just to see how much interest we're actually paying. And all you do is multiply the monthly payment amount times the number of payments, and then here we're adding on a down payment that we had to make to figure out how much we actually pay for the car, and then subtract that from the sticker price to figure out what interest we paid. So that's a simple calculation, just a little bit of arithmetic to figure out how much interest we pay on a loan like this. Now we get to mortgages, and the principle works just the same, but first we mention a little bit of terminology here. When you go to buy a house, first you have to put down a down payment, and this is cash that you pay on the house that reduces the amount of the loan that you have to take out. So say I'm buying a $200,000 house and I have $10,000 saved up, then I'll have to take out a loan for the $190,000 to make up the balance. So together the loan and my down payment add up to make the cost of the house. And these closing costs mentioned here are just an administrative fee that the bank charges that's often covered by the seller. But if we mention this in the course of a problem, the points that are mentioned with the closing cost are percentages of the loan amount. So each point is 1% of the loan amount. This is easiest with an example, so we'll do an example here. We have a condo that we're buying for $180,000 with given information, and then we go through and do all these parts of the problem. We find the down payment, find the loan amount, find the closing costs by talking about the points do a closing, and then we find the monthly payment using the installment loan formula. That's just like the car loan problems. And then here we do another example like that one car loan problem, where we multiply the payment amount times the number of payments, add on the down payment, and then we get how much we actually paid for the condo, subtract off the sticker price of $180,000, and we figure out how much interest we actually paid on this loan. So again, a useful calculation just to give you an idea of how much interest you're paying as you go through this. Here we compare two mortgages, a 15-year mortgage and a 30-year mortgage, by going through and calculating how much each monthly payment is, and then comparing how much each of them accrues in interest, how much interest you pay under each plan. And spoiler alert, the 15-year mortgage ends up being better off than the 30-year mortgage. The shorter mortgage pays less interest, although it has to cough up a higher amount each month. Then the last thing we'll do with installment loans is amortization tables. And the amortization table, the whole principle behind it is splitting each payment into the amount of interest that's paid and the amount of that payment that goes toward principal. So every payment adds up to the same amount, the interest and principal, but we're interested in how much of that payment goes toward interest, how much goes toward principal. And the way we do that is just listing out each payment, and as the balance drops, we calculate the interest for that given balance. Turns out you just have to use simple interest for that. And then whatever doesn't go toward interest for a given payment goes toward principal. So the calculations are pretty straightforward. The hard part is just keeping track of what goes where in this table. But we have an example here where we calculate each of the parts of the table and fill them all in, and then we show beyond that what this table does. So notice as we go, the idea is that each payment is a fixed amount, but as the balance drops, the interest that's owed each time drops, and so the amount that goes toward principal can rise at the same rate. So as less has to go toward interest, more can go toward principal, and that's the idea behind an amortization table. Is it illustrates that process, that as your interest payments decrease, the principal payments increase. But the interest payment and principal payment always add up to the same amount, which is your fixed payment. So that's installment loans, that's mortgages in general. And the other thing in this section that we'll cover is credit cards. And credit cards are what we call open-ended installment loans. And basically we have to somehow calculate a single number for the balance that we can use. And the way that we illustrate here is called the average daily balance method. So I won't go too much into that, because you can look through this example and see how it works. But basically we calculate the balance, which is this average daily balance, and then calculate interest on that and come up with the final balance that's owed, whatever was owed at the end of the month, plus the principal. And then we talk about a minimum payment at the end. But that's the basics of credit cards, and that's all that we cover in this section.